So we propose to use not to use the minimum rating, but to use the factor or the rating with the highest weight in your case, which is in here is the wheat production. In the other case was the irrigation system. In other case we can do it for olive trees production. So in this case, when you finish all the rating, you start to put the highest factor, the highest weight factor in the first part, and then you put all the factors. In this case, you get better result, we suppose. Okay. So finally, we made the analysis in the three cases, and you can see here the last one, or the proposed method. We can see that it's superior in all the cases. This is only 12 land units, but we had 272 land units, but of course we couldn't do it. So this is just a symbol or example of the land units. In all the cases, it was superior more than all the other classes, the other indexes. And from the literature, we found that the scientists said that the root square is the best index. But however, the root square result is less than the real situation. So in this case, we propose that if this one is more than the square root, maybe it's close to the real situation. Again, it's not clear this part. The root square, the scientists say that it's the best one until now because it's the superior one. Okay, but still the data or the result of this one is not the real. It's lower than the real situation. The value getting from this index is lower than the real situation. So we propose that this method is going to be close to the real situation, which need more investigation. So finally, we got these three maps or these three land suitability analysis for wheat production from story and from root square and the proposed one, and we can see the difference between the total area of each land use or each class. In green, the proposed one. In red is the root square, and in blue is the story index. Here you can see that in our case, in our study area, the superior classes was S3 and N1. You can see in here, as we said, in most cases, the proposed one is superior, but here is just a multiplication of all the classes. So it's not clear in this figure. But in the 272 land unit, you can see it very clearly. So finally, we could introduce a new equation. The equation, the final result of this one is usually or always higher than the other indexes, or the result of higher indexes, other indexes. The correlation, we made a correlation analysis between the three indexes, and there was a very high correlation value, was 95% of correlation between the three indexes. The final suitability index showed that the factor affecting the weight production is topography and organic matter content. In this case, in our study area, is topography, organic matter, and pH factors. Finally, we propose that this method may give more realistic result or more realistic situation close to the real situation on the ground based on the result of this one. We hope. Okay, thank you. Any questions?
I'm still confused how you validate these models. You have a method that gives you a higher suitability mathematically.
Yeah.
But why does that make it any better? if you propose that it's S1, and in reality it's N2, just because it's a higher number doesn't make it better.
Well, it's not like this, because you cannot evaluate as S2 and you get it in the real situation as N2, because you validate, you evaluate based on the real situation of factors. So these factors is already real data from the field. You got this real data and you calculate the number. So this is why we propose that it's a real situation, more realistic data. The validation, more in-depth validation will need taking points with wheat production. But even though this production is not only based on the soil situation, it's based on the climate situation, based on the fertilization, based on the management. So if we have two farmers, different management, we will have different crops, different yields. So in this case, also it's not very close to the soil situation. What we are doing here is that we say that the plane factors, which is the soil factors, is giving this result. If you put more interest, if you give more fertilizers, if you give more management to this soil, you will get more. But doesn't change from N2 to S1. I mean, from non-suitable to very high suitable. It will not change by management or fertilization, because your data is based on the real situation of the soil. So there is no way to validate except you have very huge controlled fields. Any other questions? Thank you.
If you use I think it's a recommendation for you. For next time, you can use interpolations and factor analysis. Maybe factor analysis can answer can we try?
Well, I mean, of course, it's one way, but also maybe we will have the same problem like I said. Even the interpolation is not a very strong way to validate that. So the best way to validate your result is on the graph. It's a control field with wheat production, with the same management, the same fertilization in different positions with different land units of different soil types, and then you validate this data with the field data. But even interpolation is you are using just one point to grow to all the polygons, so it's not also the same result.
Thank you.
Thank you. Thank you very much.
The next, I'm not sure. Atif? Mr. Atif Mutabor, his topic is constructed plan of wastewater treatment and reuse, a case study of developing countries. Welcome,